So yeah, welcome to emelletv, everyone. I'm Gabriel, also known as Fake News on everywhere social media. I run some courses for his script. Work at Walnut. It's an amazing company you should check out. And yeah, and now I'll host on emelletv. And now over to Dave so he can see our
Hello,
slogan.
everybody. Yeah, thanks for coming, and thanks for the people who support us on Patreon. I think we have a few people there that support us, even though we stopped on Christmas and a little bit longer. So thank you for that. I'm David. I work for Ahrefs. I'm from Barcelona, but I work remote. And yeah, we're hiring. I think Walnut is hiring as well, but my company is there. So yeah, I code in OCaml. Everything is OCaml, and we love that. We do have some reason, of course, on all the front end. But yeah, that's the plan. Today's show, it's the kind of like the big boss. So we are very excited to have this guest tonight, or I don't know, whatever you are watching this, but we're very happy to have this in today's show. So you can invite him.
Yeah, so that's emelletv, where we talk about OCaml, his script, ReasonML ecosystems, and have fun with and silly questions with hindley minute type systems. And let's get Anil back on the show. And there
Hello.
he is. Oh, that's fantastic. I need to feature this.
This is multiple. Hello.
Nice one.
Now it's my pillow. This is good.
So yeah, welcome, Anil. Nice to have you here. For someone who doesn't know you, who are you?
So I'm an academic based in Cambridge in the UK. I'm a professor in the systems research group, and these days I work mainly on climate change. I run something called the Cambridge Centre for Carbon Credits, where we're working on deforestation prevention and generally trying to reverse the trends of global warming. I've done quite a lot of open source work in the past. I've hacked on operating systems like OpenBSD, programming languages like OCaml. I built the first version of the unikernel called Mirage with Thomas Casinier and David Scott, and now with loads of developers who've been on your show. And generally, I quite like doing open source. I've written lots and lots of PHP code for the IMP webmail framework back in the days, older than many of you guys are. And these days, I mostly work on big data processing for satellites and stuff.
Nice. Yeah. So as somebody said, you are everywhere. Which seems cool, but how you do that? Like, how you are in so many like crucial projects that I think you might stop, like you were like, I don't know, having dinner or not sleeping one night, and you're thinking, how many computers do run my code, or how many, like, that you realize the magnitude of what have you done and why.
Well, the good news is that I've been involved in a lot of projects, but the bad news is because I'm quite old. And one of the great things about open source is that anything you do, normally when you're working something in a job, the code base is gone, right, when you finish. So I've been really lucky most of my career that I've been able to work in open source code that actually stays in open source. And that's why it might seem that I've got a lot of code. It's just I've been writing it for over 25 years now, and it sticks around. And that's a really, really nice thing. I think nowadays you take it for granted that we have open source code, but when I started, it was really rare, and I had to really work, to get those jobs and to figure out how to make that happen. So I don't use a computer that much actually these days, but the code sticks around. It's got weight and momentum. It's good.
True. So I like sometimes to organize my interview to know like the lifetime. So knowing where you come from, if you were a really good student or not, how you end up in academia, and like all of these questions to know you better. So the first one is like, when you got your first computer, and when you knew that you wanted to program or be part of this.
I got the first computer was a ZX Spectrum. This is one of these unique. I'm Irish, so I was born in Ireland, and we were living somewhere fairly remote. And the ZX Spectrum was a special computer in the UK. It's based on a ZX81 chip. But my first serious programming actually was when I first got online. I used to program MUDs, those old text-based games that had a built-in programming language. So I worked on something called Elephant Mud, which was one of the most popular UK-based online games at the time. And it had this built-in language where you could build scenarios like Dungeons and Dragons, but online. And it's got this beautiful language called LPC, which is actually very similar to OCaml these days. It's a functional language with object-oriented styles. And so I wonder if actually programming that MUD back in the 90s actually kind of biased me towards
made the seat, no? Nice.
Love of OCaml. And if anyone wants to mess around with games programming, I still recommend LPC. It's a fantastic little programming language.
Right. So aside from coding, let's say aside from like the screen computer, what did you do?
That's a good question. I tend to get away from a computer. I love nature, so I do lots of nature photography and sports photography. And these days, given I'm actually working on deforestation and climate change, pretty much every waking moment I find I'm usually in a nearby forest or something, learning about trees and trying to explore things about nature. Although you do things from satellites and stuff, you can't get away from the details. Generally, when you're working on any project, the details matter. And so I'm actually doing an undergraduate course in ecology at the moment as well to completely get up to speed. So I'm doing a second degree, so I can fill in the gaps, and that involves lots of field work and really getting out there. So if I'm not in front of a computer, I'm out with a little microscope, just keeping an eye on things outside.
Cool. So you mentioned the climate change from Cambridge. Could you explain what is that and what you do?
Yeah, it's pretty straightforward. About 3 years ago, in about 2019, I wanted to change my research career as a professor into climate change, and a new colleague came from Waterloo, and he joined Cambridge called Keshav, and we were just talking about what to do, and we wrote a paper on how computer scientists could help regrow forests by planting new trees. And then we showed this to some of our colleagues in Cambridge, a plant scientist called David Coombs, and he laughed at us because he said, "Well, why are you planting new trees when the rate of deforestation in the world is increasing? So before you plant new trees, stop cutting down all the old ones, right? And the old ones are hundreds of years old in some cases, lots of biodiversity, and we have to kind of stop the bleed of the planet before we go off and plant these brand new trees that will take 100 years to get to the same maturity."
Right.
And so this got us interested because we thought, well, we really have to work with conservationists if we're going to make an impact. You can't just as a computer scientist try to come along and say, "Oh, I know how to fix this problem that's been happening for 100
Refactor,
years."
yeah. Instead, a greenfield project, literally a greenfield project.
Exactly. And so we set up an interdisciplinary center in Cambridge called the Cambridge Center for Carbon Credits. And what that does is very, very straightforward. We're trying to channel billions of dollars of carbon finance, so carbon credits and so on, to projects that need it in the global south. So all the tropical rainforests in the world, almost all of them are facing deforestation right now, and about 80% of the world's biodiversity is sitting there. So we're using remote sensing techniques like satellites and so on to make it much more efficient to build intervention projects to prevent deforestation, and also to monitor them in real time. So you can get updates weekly, monthly, 6 monthly, whereas now it takes 5 to 10 years because you have to send someone to these remote areas in order to figure out what's going on. And then we're using Tezos, which is a nice energy-efficient proof-of-stake blockchain, to keep track of all of the different parties involved. Because in these worlds, no one trusts everyone else, right? Because everyone makes claims about they've protected these trees or they're offsetting this amount. The idea is to have an open database that is distributed and decentralized, so anyone can replay someone else's claim and just check what's going on. So it's a usually my test for should you use a blockchain for something is, can any one entity run a database? And in this case, there's hundreds of people cross-referencing, verifying, supplying, taking satellite pictures, and so there's no one entity or company you trust to run a database. So we're building it on top of Tezos.
Nice. So I think everybody who runs a blockchain tries to justify himself, but we kind of trust you. So yeah, that's a good.
Well, that's the point. You don't have to trust me, right? You can go look at this thing and then off you go.
Fair enough. So you mentioned that you were a professor, and we know that you help a lot of papers to write a lot of papers. How did you get into academia? Did you wanted to be a professor, and how's that going?
No. I'm very much an accidental professor. I still am. What happened was I actually got drunk at a party in the late 90s, and when I was in undergraduate, And
This is going to be good.
Yeah, that's a good one.
Stop
Clip
tweeting.
that. Start like someone should start clipping already.
And then woke up the next day, and my good friend in London, Nick, and I get offered a job at NASA to work on the Mars Polar Lander. And so we then went up to California for the first time, and ended up hacking all this crazy ground data systems code for the Mars lander. And then the lander crashed. So after 2 years, the lander went all the way to Mars, and then there was a problem in the landing jets, and then the thing just crashed straight into Mars. And I was so frustrated that I left NASA because I was like, I can't wait another decade for this thing to go back up again and stuff. And in fact, the stuff I was working on landed on Mars 2 years ago, 3 years ago, sorry, just before the pandemic. Okay. So it takes a long time. And so what I did was I decided to come back to Cambridge to do a PhD. Another childhood friend of mine said Cambridge is a fun place. Just come along, spend a few years just thinking what to do next. And I did, and then I've just kind of stayed ever since. My PhD was on virtualization and operating systems, and then there was a spin-out called ZenSource where we commercialized Zen Hypervisor. Went off and did that in open source. I ran the engineering teams and stuff for a while, and then came back to academia, wrote some more papers, designed this whole idea of unikernels. Went off, worked for Docker for a while, for a couple of years, maintaining all of that software, which is still being used, and then came back. Now I'm doing the climate change thing. So Cambridge is really good because if you're a professor here, they're really good about letting you take time off to do the things you need to get done, so your research has impact, and then come back and do and start the process again, usually in 5 to 7 year cycles. And during all this, I just keep teaching and lecturing. So it's been I really love teaching. So that's not really part of a job for me. I just love doing it. So even in the startups, we usually just go off and lecture and maintain that connection to the university all the way through. So I'm not particularly academically gifted or anything. I just seem to have been in the right place at the right time, which is usually the story for these things.
Yeah, I don't know, like classic Monday afternoon, getting drunk and invited to NASA. That doesn't happen often, but yeah, the rest of the story.
Well, if you go to enough parties, it'll happen eventually, right?
That's true. That's true. If you're paired to, yeah, cool. So like, I've been on university here in Barcelona, and in Barcelona you can, I think, are public, so you can join in public in the sense of like I can join in any class that I want, and I don't need to sign or anything. Can we do the same in your classes?
Yeah, actually, Cambridge has a long tradition that all lectures are public. So members of the public technically can show up and walk into a lecture theater, and the timetables and stuff are open. Now, unfortunately, in the pandemic, this has actually become much harder because without really consulting, all the professors and the people involved, because everything's gone on Zoom, they're not stuck behind registration portals. So we're actually campaigning pretty hard to make sure we go back to the old mechanism of openness whenever we go back to face-to-face teaching. So Cambridge is a residential university, which means that if you're here, you can usually get access to whatever you want. I've sat in some really interesting lectures on history of art and theology, on philosophy, just because I'm interested. So you just show up, sit in the lecture theater, and you see what's going on. And I've had people from politics and stuff sitting in my lectures as well. It's really good.
That's a good one. So we didn't mention OCaml yet.
OCaml? I mean, what's OCaml?
We're like, we show OCaml, but we show the mascot, but I think we didn't say the word, so how OCaml?
How did I get started? So in about 2000 something early 2000s, we were actually doing a startup on real-time barcode.
2000s.
Yeah, it was I've been using OCaml, I think, in about 2000 or so. So the background is that I worked in an operating system called OpenBSD, and in OpenBSD, it's really secure Unix, and everything's written in C. And I spent a lot of time on code audits and privilege separation, improving syslogd, and contributing that. It's all written in C code. So when I came back to Cambridge, the whole point of starting a PhD was to figure out if we could do this OpenBSD thing better. Could we figure out a way to write stuff in safer languages? And back then, there was pretty much no safe languages out there except for Java and OCaml. So in terms of systems programming, right? Obviously, things like Go and Rust didn't even exist back then. And you could kind of use Fortran or Perl with the two. And Perl is too much of a scripting language. And so, Cristiano is also in the audience there, is also an OpenBSD hacker. And Theo Rat is the head of OpenBSD, and he famously has a bad temper for bad ideas. And
Okay.
I was in a hackathon in Calgary, and actually hacked up a full SSH implementation of OCaml back in about 2003, and showed it to him. And he's like, "This is cute, but it's never ever going to get into base OpenBSD, right? Because anything has to be at least as portable as C in order to run on all the architectures OpenBSD runs on." And that got me interested in the whole. Well, okay, well that's a good bit of feedback from Theo. Being shouted at in the hack room in Calgary. And I thought it was reasonable feedback, so I'll go back and figure that out. And it got me interested in hacking on OCaml. And one of the first things I did was actually an OpenGL demo on OCaml, because we were working these real-time barcodes, and I had to build a really fancy app because the New York Times was about to interview us. And this is for some research, right? This is totally unrelated to any programming languages. And OCaml turned out to be a really good way to hack up a quick OpenGL application in less than in a weekend. And this thing was on a projector, and there's videos on my homepage actually for something called spot codes. And it was all of that stuff was written on OCaml, and that got me thinking, okay, well, if I can hack up this demo this quickly, then I might as well use it for my PhD work. And then I used it for rebuilding SSH and DNS, and then from there I had to fix a few bugs, and then there was no package manager, so I had to help Tara.
Right. So yeah,
everything.
Then the waterfall, the classic waterfall, right? Yeah. Okay. So let's get straight into like the solid questions. Usually, your teacher, if they teach you OCaml, they say it's a beautiful language. It's kind of perfect.
Yeah.
Enjoy this course because you would not see never again. That's kind of like I made it a little bit wrong, but I think that the sentence is the same. Why?
Well, actually, I actually give the same introduction because I lecture the very first year course, the very first Foundations of Computer Science in Cambridge.
Right.
And what we're trying to do when we're teaching is to normalize people's understanding, right? So people come in from many different backgrounds to our course. And some have programming, some have maths, some have done other things. And so OCaml is the most pragmatic way to teach the foundations of computer science because it's nice and easy. It doesn't blast you with mathematics in the very beginning, with all kinds of restrictions, and then you can expand things out much more easily. So you can teach core things with the core language without even showing modules or even algebraic data types, and then you can bring those in step by step. And you usually have about 3 or 4 lectures to get students to really love computer science, to get enthusiastic about the potential of this thing. So the first 4 lectures are really key because you're trying to show and kind of blow their minds with what's possible. And then leave them hungry for more, right? And that's the rest of the undergraduate course. And so OCaml is a wonderful teaching tool for doing that because it lets you cover all kind of facets of computer science, from core algorithms to sorting to machine learning. And you can hide the complexities and you can give people a simple interface with which to work. So that's the reason I love teaching on OCaml. But then when it comes to industry usage, it's interesting. I don't evangelize OCaml. I just use it for my own projects, and I've just built a lot of systems projects. And it's over the years, I tell my students, it's this is kind of a secret edge that you will have if you know how to use this language and this ecosystem. Then when you need to do something and you need to solve a problem that is a deep kind of systems problem, you want to have the tools that will support you in that. You don't want to have to fight those tools. And whatever you do, just pick any language and get very familiar with it, because that'll be the first language you will depend on when you're going out as a working computer scientist, right? And actually try to solve real problems. And for me, that language is OCaml. For other people, these days they pick all kinds of languages. A lot of them obviously pick OCaml. Some of them pick Rust. Some pick Go. Some pick Java. There's no judgment. Just learn whatever.
Right.
Well, right, and just get on with it, and solve real problems. Then build that feedback loop. So. OCaml has been very prevalent in my own career, so I don't see it disappearing. I've hired lots of people doing OCaml, but depending on where you go, the same will be true of any language. So never expect that any one thing you learn is some religious experience, right? Just go off and
definitely
go do something else with it.
Yeah, that's definitely a good tip. And you said that you were naturally like falling like, oh, there's no package manager. Let's implement the package manager. There's no build system. Let's build the build system or help building the build system. What's the end game? Like, what are really going with OCaml?
Yeah, that's a good question. The end game is that OCaml should be completely invisible, right? So any programming language is middleware. It's solving some real problems.
Right.
You've got everything from Zen to Sean building all these huge GraphQL APIs for driving websites. We've all done so much things. You building front ends in JavaScript. Ultimately, every programming language is generational. These languages code that you write lasts forever. So PHP code I wrote in the late 90s is still used in production, right, all over the place. Fortran code I modified at NASA, still used. OCaml code I wrote in the early 2000s for Zen, still used. So there's no end game except for permanence. There's a really good science fiction book called Fire Upon the Deep by Werner Vinge. And in that, hundreds of years in the future, they have software archaeologists whose job it is to go through hundreds of layers of emulation and virtualization to find a bug. There's no more original programming. There's only digging. And we're pretty close to that now, right? If you look at the layers involved in our modern stacks, it's pretty big. So the end game is purely to satisfy, to remain compiling code for as long as possible that people are writing. And OCaml is also characterized by very progressive evolution. So every single feature is made in such a way that there's a good migration path for what came before. There's very few huge breaking changes. They're progressive and incremental. So that first code I wrote in OCaml, it still compiles with OCaml 5. So some tools and build things, a few things have been tweaked, but the language, it still works fine.
Yeah, that definitely that. Well, I think we all see that when you see like some repository that's like 10 years old, you install and works. I think that's kind of unique, for sure. What are the bad parts of being backwards compatible, or as you said, like easy to migrate to? Of course, slowness, but like, yeah.
Well, no, slowness is exactly that, right? So I started working in multicore with Leo and Casey in 2013 actually. 2014 was the first public talk, and we thought it will take about a year to get that upstreamed. But when it comes to the details, right, you don't want to crash Jane Street when you upstream this thing. You don't want to crash Tezos. So that process of painstaking look at every single detail is essentially what the development process is. They say if you love coffee, don't work in a coffee shop, right? You have to love cleaning to work in a coffee shop. Similarly, if you love programming languages, you shouldn't necessarily work in a programming language. You have to love solving lots of little problems and just looking at the details. And that's what the essence of working in OCaml is. If you look at a typical PR in the language, then there's all kinds of seemingly irrelevant details, but all of them matter. If you get them wrong, then the debt builds up and the whole thing just collapses.
Right.
So if there's anything bad, it's that we took too long to build OCaml 5, because the amount of house cleaning happening for OCaml 5 is huge at the moment. There's just there's an awful lot going on.
Right. So let's talk about multicore. Multicore is going live this year.
Yeah.
And that's not the same promise as you did 10 years ago. So how was the like? Yeah.
Different timeline.
Yeah. How was the entire process? Like, if you look it back, how it looked at the beginning and how it landed now?
It actually looks pretty similar, actually, surprisingly. So when we started Multicode, there was one fundamental decision we made, which is that Casey had just come from Casey. This is Casey Sivaramakrishnan. He just come from Purdue and joined OCaml Labs, which is a group I started at Cambridge. And he'd been working with Simon Peyton Jones, who's actually now my office mate here in Cambridge. And Simon Peyton Jones had been working with them on trying to separate out the Haskell scheduling into a subset of Haskell. So if you have to write a scheduler for a language, right, because you're trying to schedule multiple threads, and something needs to say when to schedule, when to preempt, and when to run something else in a different core. And they thought, well, why don't we write a single-threaded subset of Haskell that has that scheduler there, and then programs can extend and write their own schedulers using the full power of the language. And that's what OCaml 5 now has. So instead of having a subset of OCaml, we built something called an effect system. An effect system is very, very simple. It means that whenever it's a form of an exception that you can raise that has an attached bit of data that lets you resume the control flow where the exception was raised. And you can do that exactly once. So think of it as just an exception with that additional continuation, as it's called, that can be resumed or discarded. And if you do that, that little feature lets you build exactly this idea of scheduling separately from the code that's being run, and making this possible and adding in support for multiple domains, so you can actually run parallel code, is what we put into OCaml 5, and that's actually very similar to the original design plan. What changed? The reason it took 6 years is the details. Like we wanted to make sure that there was no significant performance hit on existing code, and that's what took a good 5 years of work. Because the design of a garbage collector, which is at least as optimized as the existing one, is just incredibly hard. You got to remember the garbage collector in OCaml 4 is the result of Zerveloi, Damien Doliguez. These are just some of the best runtime designers of our generation, right? And so we were just trying to match their kind of speed and their without having their IQs, and trying to make sure that we could support this new feature while being within 2 to 3% of the other one.
Right.
But the actual spec is pretty similar to what we worked on in 2014.
Totally.
Which is satisfying.
So you said that there's domains and effects, like those are like the two new concepts when you work on OCaml 5, or would you work in OCaml 5? But there's no, as I read it properly, there's no syntactic change. So you would not have a keyboard or have like some sort of like mechanism, semantic on the language to declare an effect or to catch an effect or resume an effect.
Yeah.
When's that being planned? Does it matter? Or
that's a really good question, because one of the most observable results from using effects is that if you had a library before that exposed some kind of concurrency primitives like LWT, that library can now become direct style. So you no longer need an LWT.t anywhere. So if you're doing a blocking call, you just call the call directly, like unix.read or write, and it just works. Because an effect will be raised that will go off, and behind the scenes, the IO scheduler can take care of resuming it and waiting on the select loop and all of this stuff that LWT does. So it removes types from the language and it replaces them with a scheduler that takes care of all of that stuff. Now, because this is such a big new feature, we thought the type system support is very complex, and and certain advanced libraries like LWT could benefit from just having the lower layer of this stuff right now. So what we're recommending for OCaml 5 is that you should be able to run to port advanced libraries like LWT or the Mirage IO stacks and so on. They're all just direct style, and they internally use effects in order to run their own schedulers, but they don't export it to the outside world. If you're exporting it to the outside world, it means that becomes part of the signature. And at this point, you have a long-term dependency on it, right, for code. But if it's internal, then you can make all kinds of changes for this. So just in OCaml 5.0, because that's the MVP, that's the minimum viable product, although it's pretty good, I think. The recommendation is that you don't export effects in the interface. And then in 5.1 and 5.2, we're working on all of the type system extensions to make that possible. It could well be that the type system changes going to OCaml 6, because it's a big change. You have to track purity in the type system. It's all kinds of new theory has been developed by Leo White and Stephen Dolan, and who have been working on this for quite some time at both at Cambridge and in James Street. So it's a very complicated endeavor. So we have a few years of benefiting from all of the low-level stuff here in OCaml 5, and then we'll get safety and compositionality whenever that lands. But we don't need it right now. One of the coolest things about effects is how much they speed up your code, because you're not doing all the allocations that you had to do in LWT every time you had these boxed values.
Right.
It just means the stuff is just really fast. It's just very clean in terms of how it operates. The only complexity is compiling to JavaScript, which it doesn't directly support these effect handlers. So we're working on that, and that'll get solved very close to the OCaml 5 release.
Right.
But that's it's those kind of details we're looking at right now at the runtime layer, rather than worrying too much about the type system. So that's it's kind of staged work in order to get a release out the door before 2025.
Yeah, what it's funny is that some of us from like at least Gabriel and I, and I think many people from the chat, came from Reason. So if you came from Reason, you are very used to React, and then React got excited, or like got all the people who wanted to or loved FP, and then they started talking about FX.
Yeah.
And they said, oh, there's some languages that have it. Not true, but yeah, they were referring to OCaml, and they built a kind of like a FX system for React. So yeah,
That's pretty cool. I haven't looked at the React.
Yeah, they do have an implementation to so they land on exceptions and they rethrow, and because they realize that throwing is the only way to block the stack on JavaScript, because of course like JavaScript single thread, and then like you could only do it with exceptions. So they have like a system to so do the same mechanism. So yeah, I think should be easy to see the docs. Or even the code. I think it's easy to understand. So
the throwing promises for suspension, right? But for FX, they have like a scheduler, and like it's very similar to Meteor's tracker library, something like that.
Right.
Yeah, that totally makes. In fact, Antonio pointed out they throw promises for suspension, which makes sense because then you can use the promises and resolve those in the future.
You can resolve them somewhere else. Yeah, that's a good.
It's actually we had to think quite hard about what the low-level primitives that we're adding are, because WebAssembly as well does not give you access to the stack, so it's actually quite difficult to implement any of these handlers today. But there's a working group on adding support for stack switching into WebAssembly, at which point we can just directly implement this natively without needing all of these encodings like promises and suspensions that we have to use right now in JavaScript. So WebAssembly will actually be really clean. And I think WebAssembly 1.2, I think, is what the in theory is the proposed place where this extension can go into. But that'll take a few years to roll through all the browsers and so on, and it'll be before it gets rolled out. But the long-term future for this feature is actually pretty good.
Right. So another question that gets like very sharp. Well, I try to make it sharp. I don't know if it is. So you were part of the initial. I think you were initial group who designed OPAM.
Yep.
And for anyone who doesn't have like any idea what the OPAM, check it out. It's easy to understand. The only question that I have is like why the OPAM repository is designed this way. Like what are the reasons of like, or the drivers for
It's good. It's a good question. So we just celebrated the 10th year anniversary of the OPAM repository, and I think there's been 5 pull requests merged every day. So let me give you a bit of background into where we were back then, right, with OPAM.
Exactly. Yeah, that's what I wanted.
So I was sitting in Cambridge, and if I remember right, Thomas Gazinier was at Inria or OCaml Pro at the time. He was CTO of OCaml Pro, I think. And I was hacking like crazy on Mirage. So I was writing the Mirage TCP/IP stack, which is the most complicated thing in the world, right? Just TCP/IP from scratch at OCaml. It took a good 2 months, I think, to try to get that working at all. And it was really, really hard to exchange code. So Mirage back then was a monorepo. Everything compiled in one huge OCaml build-based build system. And anyone who uses OCaml build, this is probably the biggest OCaml build thing in the world. It's crazy. We just wanted a way to exchange code. So I was making some change. LWT had just been released. I was making some changes to it, and there's no effective way of exchanging these things. We had to commit all the code. So there was actually a lot of humans involved at the time. And one thing that was clear in the very early days was that we didn't have one set of blessed libraries that everyone could use, because some people are using LWT, and I was using my experimental, bleeding edge versions. I had to fork libraries for Mirage to remove Unix and stuff back then. And so what Toma worked with Roberto Di Cosmo and his team at IRIL, and they had this really cool infrastructure where, given a set of package constraints, you could find a solution that would work for you. And back then, that was actually pretty revolutionary, because even though now we have constraint solvers everywhere, back then only they used it on Debian in order to find a compatible set of packages for there. But we thought, why not use it every day, right, for a source-based manager, not the binary one like Debian. And it worked so well, because our biggest challenge back then was, how do we get all these islands of code? So you've got Jane Street, you've got Lexiphi, you've got the fledgling Mirage community, and there's the Coq community as well. And they all had their own monorepos. We were all using SourceForge, so GitHub had only just been released.
Right.
This is like super old school. I was using CVS for the version control, right?
Okay.
I used CVS for OpenBSD, and so the OPAM repository was a brave new step in many directions. The first one was we used Git from day one. We supported darks and Subversion, but it was all Git, and we used GitHub. And so the main reason for putting the repository in GitHub was we wanted to try this social coding thing. And so we convinced people to join GitHub. There was actually a lot of complaints about this, because GitHub itself is not free software. So a number of people when we presented this objected that we should have put it on something that was free, like one of the CVS hosting facilities or something, in order to make that work. And so we put it in GitHub, and we said that the database will be curated by human beings. It will not be an automatic database like NPM is now, where you update things. Mm-hmm. And the reason for that is that anytime someone sent in a package in, we would look at it, and we would also suggest things like, hey, why don't you go use this other version of things? Why don't you use Chamomile for Unicode instead of writing your own home one? And in the early days of OCaml, that formed a real community. So it meant that I think I looked at most of the early ones along with Thomas, actually, and maybe the first 1,000 packages we just did it. It just perseverance. And then also we also allowed for multiple versions to come in as well. So you could have older code, you could put the compilers in there, and all we did was support it day after day and just build confidence in it. And the way you build confidence is by making the repository itself as reliable and the constraints as sensible as possible. And then eventually the core OCaml team trusted enough to use it. Back then, there were also about 4 or 5 different competing package managers. There was one called Godi by Gerd Stoppelman, who's brilliant. There was 3 or 4. I'm trying to remember their names now. There was Odie, I think, for OCaml as well. And we were trying to integrate all these things, but not be confrontational, and a lot of diplomacy to make sure that everyone could use it. And so now it's quite big. It probably needs a new format now, but this is what it was back then.
Totally. Makes sense.
Oh, and Farid asks actually one very important question there, which is why can other people change versions that you release?
Yeah.
So this is also a deliberate decision, because the constraints for the versions have to be modified by other people, but not the software. So in OPAM, you can actually add patches and so on, but we're deprecating that functionality. What we're keeping is the ability to say that the minimum versions of something or the maximum versions of a package can be modified by the maintainers and not necessarily by the person that suggests the project. This is because whenever we release a new version of OCaml, we can adjust constraints to make sure that everything is correct. And so these days, you can upgrade to OCaml 4.14 almost seamlessly, because things just work on release, whereas before it took maybe a year or 2 for the community to catch up, because there's no central place to look at all these things. So we can make it so that you can change version constraints and metadata, but not the actual package itself.
Cool. So you mentioned that you wanted to try the social coding. As I recall correctly, at the beginning, the OCaml compiler was not on GitHub neither, and 208 I think was. You put it on GitHub, and then the contributions start picking up, and you made like the second phase of OCaml, like the second roundup of people going into the language and hacking on it. Now we are merging. You are merging OCaml 5 and as well releasing the new website, right?
That's right.
How do you see? Go ahead. Sorry.
Go ahead, Dave.
I was thinking, how do you see these core improvements, kind of the accessibility of everybody that lands into the language, like what people call meta language?
Yeah.
How do you see those changes applying to OCaml? The popularity, haters, lovers. Yeah. How do you see the wall effect for these changes?
It's an interesting question, because it makes you ask, what does the community want, right? So is popularity our goal? Is stability our goal? Is security our goal? What are the values that we're trying to optimize once you decide on those things? And the GitHub itself was interesting, because so I created the GitHub OCaml org for OPAM, and then the compiler saw how well that was working, but it took 5 years, and then the compiler is highly conservative, as it should be, and there was a real fear that if we open this up, we'd get flooded by too many PRs. And in fact, it forced us to adapt our core development team practices, because we did in fact get lots of new PRs, and we had to bring in lots of new developers, and Xavier created lots of new rules, and essentially told people to start reviewing PRs more systematically. And it's been really healthy. It's been a good process. And so I had the same hopes for V3, because when the V2 project started, it was Ashish Agarwal in 2011 at the OCaml users conference, the first one. And that was so revolutionary then, because the old OCaml website was a thing of legend. It was camel.indra.fr. It's very, very old school. And I think it served us really well for a few years. But then it ran out of steam because eventually all the maintainers they have jobs and lives, right? So they ran out of time, and then it was left with just me maintaining it. And so I thought, well, we actually have all these new people in here, and the community is growing wonderfully. And so how do we bring them in and let it reflect what they want to happen? And so this new website was actually it was started by Ashish and myself, from the old one, but it's largely been taken over by a whole new generation of really talented designers and hackers. It's been led by there's a developer called Kanishka who initially prototyped a whole bunch of really cool things in Reason and we're using Vercel, and then we integrated a lot of the other pieces like the documentation website, and so Thibaut Matteo and Patrick Ferris have taken over now, and they've built all the infrastructure as one unified server. And then John Dudley built the entire package search for ODoc along with the ODoc developers. So this new site, I think, will help us discover what we want as a community, because it's simpler, it's more modern, it lets us discover things, but it's also got some interesting new principles in the website. It doesn't have any third-party trackers, so we don't know who's visiting the website. It's got absolutely no third-party cookies or anything like that, no Google Analytics, nothing like that. And we're also putting in carbon principles. We're saying that these are principles in which the OCaml infrastructure, not just the website, but the OPAM build infrastructure, which is 2,000 cores, rebuilding these every day. We're going to track the carbon. We're going to make sure that it's necessary emissions. We're going to make sure that it's hosted in responsible green systems. And for the emissions we can't avoid, we're going to offset as well using using things like trusted carbon credits. So these are new values that didn't exist 10 years ago. 10 years ago, we were really excited by Google and that we could get Google Analytics. Now now I kind of hate them. So it's helping us to find what we want. And also, and for the new users, this is where we need you all to help us, right? So look at it, criticize it, send PRs, and do that relentless polish that is what is necessary in order to get a really good website. So far, it's only been about maybe 10 people working on the site, and that's, as you know, for a huge website, that's nothing, right? It takes the whole community to come in and apply that final stage. So I really hope we're going to put it live really soon, and then we're going to need you all to submit PRs and keep fixing it.
Will be cool. So I think the next question is kind of like mandatory. When we're gonna have like OCaml Conf? Like I know that I don't even know if it's planned or anything, but
we were actually meant to have a OCaml Conf in Cambridge last week, but because of the pandemic, everything got cancelled. So we had this beautiful place in Queen's College, and everything was booked in 2020 actually, and it's done. So we need a OCaml Conf. We normally have the OCaml workshop at ICFP, so it's actually going to be in Slovenia in September. But that's actually quite an academic conference. So even though anyone's welcome to attend, it's associated with the big ACM conference and so on. So I think at some point, I'd love to see a more informal, interesting, fun OCaml conference, and more like the mainstream programming ones. But hey, you're in Barcelona. That's a great place to do it.
That's a perfect place.
I think we'll be happy to do that in Barcelona if you.
Yeah, that would be amazing. So yeah, that'd be cool. Of course, like when the world allows us to travel, that would be perfect. So you mentioned Tezos. Sorry, go on.
No, it was really nice to have the OCaml workshop was fully online and free in the pandemic last year. So accessibility is also really important. I think I'd love to see more online things, like stuff like you're doing here with Twitch is absolutely fantastic, right? Because this conferences are good for socialization, but not for you don't have to fly halfway around the world to have technical discussions. We can have them right here. And I think I'd love to see more of this style of things, as well as having a big conference where we can hang out and get drunk and find new
So somebody came to me say, I love the going to meetups. I hate the social, like the part where everybody hangs out and eats. I cannot do that. Thanks for doing Twitch. So for many people can come and join us.
Totally. I like
that. You mentioned Tezos, right? We're not getting in very deep into crypto or anything like that. But how do you collaborate with Tezos? Why is such an important piece on OCaml? And why it's playing a big role?
Tezos is not that important for OCaml. So it's just another system built using OCaml, right? So it's interesting because the consensus mechanism in the smart contract system actually hashes the entire toolchain used to build the Michelson language, which is used for smart contracts, and that actually hashes the whole OCaml compiler. So it's interesting from a programming language perspective because it's just a really neat use of OCaml where everything is pulled in for the dependency chain and it's all carefully tracked. I find it fascinating because I've always worked in distributed decentralized systems. So I originally set up Mirage because I wanted to build these personal data management systems that were independent of tracking, that were permanent, and could be used by people. And that's still, what drives the Mirage community, right? I have a unikernel file server in my home. It's all good. But what Tezos represents is that it tells us how to build permanent distributed systems because apart from all the consensus stuff, it's got this meta consensus, which is a voting mechanism where you can decide how to upgrade itself based on votes. And so it just upgraded the entire algorithm at the heart of consensus with a new one called Tenderbreak, and it happened without any interruptions. It was just this beautiful kind of way of having the community vote and deciding where things will go. So this is really important for building not systems that are efficient or secure, but that will last the test of time, right? Because the only thing we know is that things are going to change, and so when it comes to working on climate change things, a lot of the projects that I work on these days have to last 40 years. We just got Cambridge to commit to 100 years of tree replanting. Now, Cambridge is an 800-year-old university, so it'll probably do that. But 100 years is older than the internet. So what systems are we going to build now that will actually last the test of time? Well, I'll tell you what, right? We're going to build it on OCaml because it's 25 years old. It's one of the oldest programming languages in the world. It's about as old as C by some interpretations. And then you want to build in the ability to change and to evolve and to react to new hardware and new software and new system threats. And so you need to build in into the distributed system the logic to get out of an evolutionary dead end, and that's what Tezos brings in. So I'm actually editing the Wikipedia article for Tezos at the moment to add in the list of upgrades and to categorize them by, what was the fifth upgrade and what did it do and how do you map these things out? So I'm just endlessly fascinated by that aspect of Tezos.
This one is very important. It's actually one of the biggest discussions among Ethereum developers, is because the protocol just keeps getting bigger and bigger, more corner cases to maintain, and they just now we are going to do the merge. And how you're going to maintain all of these features that are coming in the future. It's a very important topic.
Yeah, I totally hate that about the computer industry, right? Because everything I've worked on has been trying to get rid of layers. So in OpenBSD, we are proud when we delete more code than we add. In unikernels, it's all about how do you get rid of the operating system and just have exactly what you need. And in Tezos, it's all about how do you evolve and shed weight as well as add new features. It's as important to remove unnecessary things in an upgrade as it is to create the new ones. So a constant time code base, a constant space code base would be really nice if we do that. We need more of this sort of dead code elimination everywhere.
Right. Killing the layers. Yeah. So what's your opinion on BuckleScript? BuckleScript was born in Bloomberg by Bob.
Yeah.
And what did you thought when Bob opened the pull request and says, I have an idea, I have a fork of JS of OCaml, it's going to be amazing, and then everybody bashing on him? What was your first thought?
I mean, you gotta bear in mind the core developers are very agnostic to uses of OCaml, right? So because we see all of the uses of OCaml, so there's just so many things. There was let me see. There was people compiled OCaml to 8-bit microcontrollers, to all kinds of stuff happens all the time, right? So we saw the pull request. The first thing we do is just break it down into, well, what part of core OCaml does it affect? I don't really care what the use of it is because we want to support as many people as we can. And Bob was actually doing a PhD in somewhere in the east coast of the US, one of the big schools there, and he had loads of really, really cool ideas about metaprogramming and CAML P4 and how to make all this more effective. And a lot of those ideas kind of weave together to form this idea of this bidirectional language. So there's two halves to the first reaction. The first half was, this is really cool research, because the idea of having this a bidirectional programming language syntactically that will be human readable is a really interesting one. There was a chap called Rob Ennals in Intel Research Cambridge in 2005 that built something called Jekyll and Hyde. It did the same thing with the Haskell-like language and C on the other side. So I'm familiar with that idea, and it's a really good idea, but it's also very, very difficult to get right. And so you had to take lots and lots of compromises. And then second bit is how does it modify OCaml? And we had a very straightforward conversation at something called the OCaml. The Camel had an industrial consortium where people can get together and present ideas. And it became obvious fairly quickly that Buckle script is not OCaml, right? It did not aim to maintain compatibility with OCaml. And yes, OCaml explicitly maintains compatibility. So this immediately tells you that there's more than enough room for both of them to coexist. Because if you're building custom code bases and you don't care about the OCaml library ecosystem and you're just writing everything from scratch, and you're mainly binding to JavaScript libraries, go use Buckle script. If you're compiling a huge OCaml code base, go use JS OCaml. If you need to do both, use both, and interface them through JavaScript. It's all good. So there was very little drama, from our side. This is all good stuff. We're happy for Facebook and doing what they're doing. Now, some tensions can arise if there's an expectation that the core compiler will take those changes. That is simply not true for anyone. I've had changes rejected for Mirage. I've had changes rejected for Zen. It's never a personal thing, right? It's the core developers' responsibilities to look after the health of the crown jewel, the actual OCaml compiler. And once you take a feature on, the person who contributes it normally disappears unless they're one of the core maintainers. And then you're responsible for maintaining it for the next decades. And I mean decades. Like some of these things, we're now fixing bugs from 14 or 15 years ago in OCaml 5. So we're going back to the bug trackers. It's just amazing how much work there is to do that you don't appreciate. So that's a reason why something's rejected, because either it's not got a good enough support story or it doesn't fit into the bigger picture. But maintaining forks is completely fine as well. And OPAM makes it easier to maintain forks. I think I merged in the Buckle script fork into OPAM repository, when it first came out, and it was totally fine.
Right. So following the next question, going a little bit deeper on the drama with a lot of quotes. ReasonML, it's a new syntax. Do you care about syntax?
Do I care about syntax? Well, I care enough about it to have supported OCaml format, so we added that to the OCaml platform, purely because once you have mechanized formatting, then you don't have to care about syntax anymore, right? Anyone else can use whatever they want. So one thing I liked about ReasonML was that it had this bidirectional transform again between OCaml and Reason. And indeed, F# had the same thing. Don Syme added that to the first version of F# as well. It had a OCaml compatibility mode, and you could compile a lot of OCaml code. Syntax does matter, yeah. Syntax is a user interface to your programming language, and ultimately, if you have lots of scary-looking syntax, it's a very subtle thing that requires endless debate, because it's also developed never with a big picture, but with accretion. So there's been 25 years of syntax upgrades to OCaml, and so you've got to look at the lexical history of it, figure out how to compile old code and new code, and there's almost no symbols you can add anymore. That
run out of symbols.
Well, the biggest thing that we did was that took us 4 years was to migrate from CAML P4 to PPX, and because it was becoming unsustainable. In the old days, you had to compile up maybe 20 CAML P4 extensions, layer them in the pre-processing pipeline, and then you would not only have a slow compile, you would not be able to recognize the resulting code, because CAML P4 could modify any part of the syntax. Right? Mm-hmm. And it looked really cool because you could just say type T with SX or with JSON. But what is this with? What's it doing there and not somewhere else? And it became very hard to use. So PPX said we need a more structured syntax. We need to add extension points. There was literally years of discussion. You can go to list.caml.org if you want to see the working group and so on. And then now we have something much more predictable. And so the fact that Reason can transform back and forth from OCaml is because of the decisions made in the core compiler to remove all of these extensible syntax pieces and so on, have a nice simple syntax, and with OCaml format now, it's actually pretty easy to go back and forth. So if you prefer the Reason ML syntax, use that, transform it back. I use OCaml myself, so I don't use the Reason syntax, but I'm very happy to get pull requests that come from Reason. I often get that in a lot of my libraries like YAML and so on, and it's all good. I have very few religious views on programming languages, so other people seem to care a lot about syntax, but I only care about is it affecting the core compiler, and is it really, really bad? In which case I'll have an opinion, but most of them I don't see those.
Perfect. So if you wouldn't land in OCaml, if you end up with a C solution for OpenBSD, what what would be your favorite language? What would you be coding when nobody's watching?
Well, I mean, I must admit, I do code in OCaml and no one's watching as well. It's a very good language. But I'm really into F-star at the moment, actually. So F-star is I'm generally into languages that help you with the ability to apply formal methods to what you're doing. That's why OCaml attracted me in the first place. And these days, the most exciting language I've seen that I'm messing around with at the moment is a PhD student from India called Dennis. He wrote a language that lets you write the French tax code as a formally specified language. And by writing this stuff mechanically, he found real bugs in the French laws, and so they found actual holes where the laws as applied didn't match the actual code. So now I'm messing around with trying to apply that to climate change policies, because every country has different laws for accounting for carbon and so on. So my dream is, hey, if we could formalize all these in this kind of style, then we can actually find bugs in kind of carbon policies around the world. So that's my kind of, not exactly my relaxing language, but it's the language which is really out there, right? It's a very different. It's called Katala lang, and if you want your mind kind of stretched, I would definitely recommend coding in that.
Yeah, I read that code because like I speak Spanish and Catalan, and I thought, wait, what? Like how like what are the odds of having? Okay, so and then I read into it and then said, okay, it's law related, has nothing to do with the real language. But yeah, and then I saw it wasn't OCaml, so like yeah, that was like.
All right, this is next week's show, right? You got to live code you learning Catalan.
Yeah, that's a lot of levels again. So yeah, definitely good. And we got a question that we didn't throw at you. There was like, what advice would you have for a student in CS who wants to participate in a project against climate change?
Ooh, it's a good question. In fact, is that email? Because I think I haven't replied to your email because I was in the jungle. I apologize for that. It's a really good question. I would break this down actually into, don't look at technology to start with. So first of all, look at the problem itself and think, well, how do you bisect that into smaller and smaller pieces? And only when you come to bisecting something that needs to be solved, do you then go and say, well, okay, now I have some skills from computer science. How do I apply that to make this thing faster? Don't start from a mindset of, hey, I can write code and then I'm going to hack my way through some problem, because it's good fun. But usually most problems in the world can't be solved with code, right? Usually there's some outcome that you want to achieve, and that terminal outcome, that final state of the world as you want it to be, can be helped by technology, but there's often many other things you have to do as well, in order to make it accessible. A good example is if you, for example, think I want to help farmers get access to weather information because it'll help them predict heat waves because of climate change. And then a CS enthusiast would go, I'm going to build an app for this and add in all these fancy features. But the reality is, you have to make sure the farmers can access it on their phones, which are often obviously older models. You have to make sure they can pay for pay-as-you-go subscriptions. Make sure they have reception in the area they're in. Make sure that there's equal access across. So you're not giving unfair benefits to just one community. There's all kinds of problems when you come to real world climate things. So my advice for a student in CS is to go work on real projects, and then try to figure out how the skills that you've learned in CS can be applied humbly to an existing problem. And sometimes I mean writing some really boring code, like I built just websites for people. When I joined the Conservation Institute in Cambridge, I spent about 6 months doing Python consultancy, right, for a bunch of and that was more valuable than probably anything else I've done over there, because it's just helping them optimize their code. You just solve whatever problems need to be solved, and so don't say, I love OCaml, I want to use OCaml for climate change. I spent a year basically learning from them, and then said, oh, I've now found a few things that need to be solved, and I'm happy to be using OCaml for those, but it's just a detail, right? It's really the outcomes that I'm trying to solve that I'm focused on. And there's loads of local groups you can get involved in climate change. That in every city in the world now, there's everyone from Extinction Rebellion to slightly less activist, but also slightly less fun groups that are working on the day-to-day problems. And I would encourage you to go along to them, learn from them, learn about the issues, and then get involved. Although there was one project though that I'll find, which was when we were doing the outreachy for OCaml, we had 5 funded spots, and one of the projects was really interesting. I think it was called Citizen Lab. If someone could Google for me, it's called, I think, Citizen Lab for Science. What they were doing was anyone could come along and contribute with local observations from your cities, with measurements and so on, and then scientists could come along and try to kind of classify those and give you a bit more information about your neighborhood. So if you drop in a sensor for humidity, they would tell you what's going on, if it's abnormal and so on. So we actually gave one of the OCaml spots to an intern who wanted to work with us, but she really wanted to work in climate change. So she worked in that project instead. I think it was in Python. And we were really happy to do that, right? Because we're all in it together. They didn't have enough funding. They had a student that wanted to do it, and we were very happy to support them. It's Public Lab. Patrick, thank you very much. It was Public Lab. And Patrick here is the one of the driving forces behind our outreachy work, along with Sonia Hines and Gargi. And it's projects like this, I think, which are really interesting because they're already established. They've worked through a lot of the not useful computer science bits, and they're established, and people are really using them. And then you can go and contribute to those. But having said that, obviously, I'm going to be releasing a lot of OCaml source code for working on basically on satellite data sets and so on. So I'd be very happy to. I love this Twitch format, to have a Twitch show where we can maybe live code our way through some of these things in OCaml. I know that other community members have got GeoJSON and various other mapping formats under development at the moment. So I think we could try to pull something together among our community as well.
Nice. So yeah, I listen to this advice as something that it's applicable to not only climate change, not only OCaml, like basically any kind of like startup or any kind of like company or project, like should, like, of course, play around with the language, enjoy the language, like learn kind of basics, but of course, like learning the domain where you're working first, or the user or the real person or the problem. I think it's a life advice. Like go like, don't think that you have like any sort of like experience. Join the problem and then go back.
It is one thing I do like in the OCaml community. The community is pretty humble. You know, they're all we're all pretty good at not being popular. So we tend to go off and
you need to be nice. Yeah, there's the only way. Right. And one question that I got. Sorry, Antonio, for overlapping yours. What the prototype of person that writes OCaml uses Linux? I think I saw a few surveys here and there. Even the last survey from the forum was like from WT had many users from Linux as well. What happens with the Windows users? We have some story about cross compiling. It had never been perfect. So and we talk about accessibility and we talk about all of this. What happened with the persons that wants to play some games and then later do some OCaml?
Yeah. So the very quick answer is use WSL2, right? But that's not a good answer. But that's a very quick answer. But actually, the core compiler has had pretty good Windows support pretty much from day one. So original companies like Lexiphi, for example, and my own commercial use in ZenSource, we shipped OCaml CLIs and applications on Windows in the early 2000s, and a lot of those have been shipped ever since. The problem arises with the tooling, because when you have and it really was when OPAM came along, that's when the problems really began, right? Because we didn't have Windows support into OPAM in day one, and I still think that was a mistake. Because we were also just a tiny team, obviously. But if we'd done it then and maintained it, then we would have been able to continue Windows support. But OPAM grew so quickly, right, with thousands of packages, that our CI systems, we had to rewrite them every 2 years to cope with the additional scale that was happening.
Right.
So initially, Travis was launched. We had some shell scripts, and then Travis was launched. And then we overloaded Travis, and then there was something called I can't even remember the BuildKite, and we got kicked off BuildKite, crashed the entire website, and then we wrote something called Occurrent, and so we're really busy just writing the CI systems for that. And the
last version is Occurrent, right?
Yeah,
like,
Occurrent, right?
You like your own implementation, right? You get tired of the third parties.
That's right. Yeah, so it's actually based on some code that we wrote at Docker for orchestration of containers, and then we extracted out the cool bits of it. It's used. It was originally used in Docker for Mac and Docker for Windows, something called DataKit. And in fact, I think it's not in the latest builds, but it's the thing that coordinated all of the the launching of all the various Docker processes on your Mac or your Windows machine when you click in the app. And then we took that. It was actually quite feature complete because it had to cope with lots of corner cases. And OCurrent was Thomas Leonard wrote the Docker stuff at Docker, and then he came to OCaml Labs and he wrote the OCaml version. And then on top of that, we've been adding cluster managers, something called OCluster, which can run across various clusters. But the key thing is that we now have support for Windows and Mac machines as well. So and this means that almost any container-based system doesn't work because it doesn't work on Windows or Mac, right? It works in Linux. So initially we had a container-based CI using Docker, and before that Zen, and that really helped with Linux, but it didn't help us with Windows or Mac. So now we actually have workers running Windows machines that is beginning testing. So we should be able to have Windows CI support for OCaml repository quite soon. And then on top of that, there's been community efforts. So apart from the OCaml platform team, who are been working through so many tools to add Windows support, right? So in the background, individual tools are all pretty good with Windows these days. A contributor called Jonah has been working on a full installer constructor for OCaml. He's been posting on the forums. Yeah, and that's really exciting because that just means if you want to just distribute a binary, she will use Jonah's stuff and just go build a binary, and then it'll take care of all of the end-to-end things. One thing I observed is that Windows support is actually pretty bad on many languages. If you've ever tried to cross-compile with C bindings from Go, for example, it's really easy until it becomes really hard, and then it becomes basically just impossible. So OCaml is in the middle point where if you're determined and you want to do it today, you can actually build Windows binaries. We've done that for Docker. Like we ship millions of Windows binaries every month with the Docker for Windows. There's a lot of OCaml code in there. But it does take crafting and knowing your dependencies and making sure that you understand them. Hopefully, over the next few years, we'll get to the point where Windows is just natively supported. But ironically, as soon as we get Windows support natively with Visual Studio, it's less necessary because WSL is actually pretty good. So you don't need it quite as much.
Nice. That makes some hopeful. Yeah. So I would love to extend that for like 3 more hours, and because you have jet lag, I heard that you have jet lag from Peru. So
you should totally bring up. You talk about Windows for many hours.
So the last question would be us, like, of course, like we're doing the emelletv, of course, like, but me as a member of the community of OCaml or regional OCaml, whatever, how can we help? Like, aside from being there on the forum, on being helping the pull requests or pointing to documentation errors, like what are the low-hanging fruits or the big projects that we can contribute as a members?
I think if I had one ask, it is if we want to have an inclusive and an open and a balanced community, is that people really just step up to help mentor newcomers. This takes a lot of time, right? And I did in the early days with the GNOME Summer of Codes, and now we have Outreachy as well. No one is responding to our requests, apart from 1 or 2. Really, we really appreciate it. Just to spend a few hours helping to bring new people on and trying to, just trying to make them feel more welcome. And we've had some amazing contributors come in from these programs from outside who are coming from areas where we're completely underrepresented, right? So one of the ODOC contributors, Lubega, just came in from Uganda. He doesn't know anyone around him who works in OCaml. He learned enough to make major contributions to ODOC, and it's just really great fun to work with, right? And these examples are replicated everywhere, and so Outreachy is a really nice program because it means that I think we have a really kind and a welcoming and a fun community to be around. But we need to be able to spend time with newcomers in order to make them feel welcome and to bring them on board. And we know that the onboarding process for OCaml is quite tricky. So even just 1 or 2 hours spent with an Outreachy intern in the beginning of their internship it builds confidence 1,000 times over, right? Because how stupid would you feel? Like, how stupid do you feel if you're coming into this community, you've got this Outreachy thing, you've been funded, and you can't get the thing installed, and you think it's your fault? But often it's because of some small bug or small thing that we just fix immediately. We have to fix that in our tools, obviously, but also just spending a little bit of time helping people is so very, very valuable. And I've seen that among the people here on Twitch, right? I've seen like Shohan and Antonio and Eduardo, like everyone just helping people on Twitter, on various mediums, on Discord, for example. And I know it's possible because we're doing it right now. And so just keep doing more of that. But in particular, the thing that could really use help is outreach, I think, because it's been very kindly, it's been funded by the Camel Software Foundation, by Carides. They're very good at doing that, but we can't fund the people, right? You can't force people to take part. Love to see that. Nothing would make me happier than 10 outreach interns every time with 20 mentors. And of those, if just a few of them stay, we'll have a more robust community, I think.
Right. Let's not forget that Antonio, that I think he's close to be banned from Twitch to repost the same question and go back to climate change, which totally destroys the flow of the conversation, the interview. But whatever, let's do it for Antonio. Go back to climate change. I think you kind of replied that one, but go on.
It's a pretty good place to end, because that's kind of where my heart is right now. The things I'm working on. So Antonio, we're working on we're working on trying to figure out, first of all, how do you stop deforestation? And that's kind of both mitigation and adaptation, right? Because we have to deal with the reality that the temperature will increase, and so forests themselves are increasingly under threat just because of temperatures rising and droughts spreading and so on. So we're trying to figure out how do we get enough intelligence to make sure the forest can adapt to these situations. And then the mitigation just comes in from the fact that by pumping finance into projects where there's alternatives to deforestation, for example, local livelihoods can be maintained through other industries other than plantations and soy plants and so on. That helps with making sure that we can avoid the emissions from these effects. But essentially, the terminal outcome is stop deforestation and then increase in later phases other carbon sinks such as seagrass, which is underwater, and mangrove plantations. Help with healthy agriculture practices. So things like peatlands, for example, are drying out all over the world, and we're trying to combine the sensor data along with the science to just export exactly what that is. And then whether or not that's mitigation or adaptation, it depends on what the actual project is. But it's kind of a combination of both across there. But we know that we have to measure the health of the world as it is today in order to make that possible. And just very quickly to answer Dozen Golf about how much of a time commitment does it generally take to be an outreach mentor. It depends how much. If you want to do just one kind of matrix or Zoom call with the intern just to welcome them, then that is totally fine. You choose how much it is. There's a time commitment of trying to meet them once or twice a week if you want to be a full-time mentor, but there's no reason why you have to be a full-time mentor, right? Just do what you can. It's all volunteer work, so it's you're not being judged on if you're spending 1 hour or 2 hours or 10 hours, but you're being judged for spending 0 hours. If you just do a little bit, it would be really, really nice, because it just shows you care, right? It just shows we care as a community.
Totally. So yeah, I don't have any more questions. Of course, if I do, but I think it's gonna be on some OCaml Conf or some getting drunk on Cambridge bar. I hope so. Yeah, I think that was like a really, really, really amazing time. So if you have anything to say, feel free to.
I just want to say how much fun I've had, and I've got a Twitch account now, so I'm going to go explore some Twitch channels, and I hear Eduardo does some live coding. I've heard rumors of this, so
yeah, non-stop.
If you're logging on, I'm going to discover this new world as well. So I just thank you for having me on. I hope to see more OPAM PRs from you guys, what you're working on, and in return, I promise to make sure that JavaScript is in fact supported when OCaml 5 is released.
Perfect. That's a good.
We're not going to forget.
Right. Yeah. Yeah. So thanks for coming.
All right.
And yeah.
In that case, I'm going to finish my gin and tonic that I've had here. Just staring this whole time. You didn't give me a chance to have a drink.
That's true.
Thanks. Hopefully, see you all soon in person, especially you, Antonio, because it means we'll be in California, and I'm going to go sign on to the Eduardo Twitch, which is just beginning.
Cool. Thanks everybody to join the chat. That was lovely. So many activity. So much activity. So thank you.
Thank you, everyone. That was pretty fun. Had a great time. Thank you, Anil, for your time. That was like very nice. I hope to see you soon again here on OCaml 5 and multi-core of algebraic effects and like a word domination for sure.
I'm going to be in the audience, right? That's one of the rules, isn't it?
Oh, that's the rule.
See you later on.
See you.
See you guys. See you, everyone. Till the next one.
Bye.
Good night.
Bye bye.